We are now joined by the CEO of Scindo, Dr. Gustav Hemberg. Welcome, Gustav. I'd like to begin today's conversation by asking you, what can you tell us about the process by which you developed your proprietary enzymes?
Thank you, Julie. So we've used a bottom-up approach by initially identifying novel enzyme functionality capable of cleaving molecular analogs, incorporating some of the key components of difficult plastics, then increasing the length of the carbon chain to more closely resemble plastic polymers, before finally starting to work with full-length polymers. The primary technique we use is directed evolution, essentially a sped-up lab version of Darwinian evolution, to redesign the active site of the enzymes to create a better artificial fit around these non-natural substrates to allow for a faster and more specific degradation.
And what is your go-to-market strategy to get these enzymes to the market quickly?
So our long-term vision is to use our enzymes to enable breakdown of mixed landfill plastic waste. However, initially, we'll be working with an existing recycling infrastructure to upcycle low-value byproducts as novel feedstocks for industries currently dependent on petrochemicals. So we're specifically targeting crude waxes that come out of the pyrolytic breakdown of plastics. We'll convert these alkanes into aliphatic aldehydes that serve as core components in the $32 billion fragrance and flavor markets. Roughly 95% of the chemicals used in commercial fragrances are derived from virgin petrochemicals. And we will enable a new, cheaper feedstock to help promote a more circular fragrance and flavor industry. These type of aldehyde products can also be further converted into a variety of key chemical building blocks, for example, in the $40 billion surfactant industry.
And it sounds like you have a number of markets at play here. What can you tell us both about the market of plastic breakdown and use of this in waste facilities, and then using those plastic monomers to create things for example, the surfactant industry?
So to be truly impactful, it's not enough to simply break down plastics. And we're enabling carbon recycling by using the waste as a feedstock to manufacture key building blocks for other chemical industries. And there's currently large appetite in the consumer goods market to replace chemicals that are derived from petrochemicals with components from more sustainable or circular feedstocks. We received excellent traction from several of the leading corporates in a variety of sectors, including fragrance and flavor, petrochemicals, surfactants, and specialty chemicals, about this business model of using plastic or plastic byproducts and converting these into replacement for petrochemicals to enable a more circular economy. In addition to this, we've also had significant interest in applying our enzyme systems in converting natural oils into certain chemical ingredients to enable novel natural feedstocks to replace petrochemicals.
And can you talk about the differentiation factor? What will help Scindo to succeed in the sector of breaking down some of these plastic compounds?
So the use of enzymes to recycle plastics is an early but quickly emerging sector. And I think that what sets Scindo truly apart is that we're not only targeting the breakdown of polyolefins and vinyl plastics, some of the most difficult plastics in the market, but the generation of high-value molecules from these feedstocks to service a broader chemical industry.
And can you give us a brief insight into how you will protect your intellectual property around these enzymes?
Yeah, so we're currently working with our IP lawyers, CMS, to put together our first patents for our enzyme systems.